Continuing our discussion of reaction mechanisms, we are going to look at labeling reactants in mechanisms. And what we have here is a mechanism you'll see much later in this course, but right here, I've got the mechanism on here for you. Eventually, you're going to learn how to do these mechanisms. Right now, you're not feeling good about that, I know. Okay? So right now, all we have to do is use these labels. There's 6 of them. Every reactant has a minimum of 2 labels on this question when you see it on the test. Every time a molecule reacts with another molecule, at least 2 labels, potentially 3. Okay? The labels being Lewis acid, and if you remember this cute little memory trick, you got to pretend there's no E in front. So you're talking like you're on the street. Electron acceptor. See that? Why'd I do that? Just because I'm a goofy guy? Not really. I got LA. See that? That's why you should do electron acceptor first. Lewis acid. Then you know Lewis base by default, right? I didn't mention it yet, but when you hear the word Lewis, what are the only 2 words that ever should come to your mind? Don't say structures. Please don't do that. Lewis is a little more general than that. It's what special kind of electrons. The electrons we can do chemistry with are called valence electrons. From now on, when you hear the name Lewis, you don't think Lewis. It's a waste of time. It's the guy's name. It means nothing. Lewis means valence electron. So when you're asked for definitions and Lewis is in the words, you better be talking about electrons, right? So when I say electron acceptor, I hope you understand valence electrons, right? Okay. So Lewis base, just flip it over. I don't have a cute memory trick for you on this one, but hey, you got the trick for the first one. They're opposites, right? So what's a Lewis base? Electron donor. And Lewis acid is synonymous for reasons that the definition will show with the word electrophile. Synonymous. See? Wow. Wow. Okay, I just want to write the word synonymous over there. It's not letting me. Synonymous. Bold and right point out. Why not? You still read it? I like it. Electrophile. Hey, electrophile is its own definition. Any word in science that ends with phile, what's that mean? Phile at the end. Lover of, like, go with it. Lover of, yeah. Philia is love. Yeah. So electron lover, right? I mean, electron acceptor, why would it accept them? It only accepts them because it loves them, right? Yeah. So, I mean, it's kind of obvious why they're synonymous. Electrophile, electron acceptor. I'll write down it's an electron lover. I really don't have to. And another pair of synonyms are the opposites over here. Nucleophile, nucleus lover. Now look at these 2 definitions, and I mean, what's in the nucleus to love? What charge? Positive. What's the only thing that loves positive? Sorry, what's the only thing that loves positive? Say it again. Negative. What's the only thing that's negative? Electrons. So you better have electrons, right? And be willing to donate them, right? If you're loving a nucleus. The only reason you love a nucleus is because you've got electrons, probably a little extra, right? Yeah. And that's those two are also synonymous. So there's your minimum labels. You're always going to have one of these two, or two of these, or these two for a species. Now the ones where you don't always have are the Bronsted. And when I say the guy's name Bronsted, what are you going to think from now on? Instead of it's a guy's name. Pretty sure he was Dutch, but I can't promise that. I don't even know if I don't think so. My history's getting old. It's rusty. Is that too faint? It shows up pretty well. Bronsted acid. Now, when you do Bronsted, the one word you have in your mind is proton. Bronsted is just about protons. It's a different perspective of looking at things. Okay? Now, you're a proton donor. And a Bronsted base. Proton acceptor. There you go. So we got everything we need to do our label. Now the start of an arrow, I like that. Arrows always, this is attracted to this nucleus here because you know why? It's got an anion and that nucleus is a little bit positive. You don't really need this as part of your answer. That's a slightly polar bond, right? That's why it loves the nucleus. So what do you call it when it loves the nucleus? Nucleophile. What's the synonym for nucleophile? Okay. So anytime you write Lewis base, you also write nucleophile. And I like it because it looks like a name. Lubnu. Lubnu. Okay, it doesn't look much like a name, but sounds like a name. And a Lubnu always reacts with something that loves electrons. What do you call that? Something that loves electrons? Electrophile. And that's synonymous with electron acceptor. LA. Yes, sir.
Yeah, question. So about the first carbon, when you put the electron, the one pairs to the carbon with the bromine.
Yes, boron. Yeah, bromine. Sorry, yes. Bromine. Yeah.
That's like active violation. How is
No, it's making a fifth bond, but breaking the fifth bond at the same time.
which one? Which one is that way?
The carbon bromine bond is gone. You want to see it? Here it is. Here it's gone. It left. There you go. I didn't show that, but I often don't show stuff you don't need. But when you're first learning it, it is good to see everything. So I appreciate your concern. Yeah. And don't confuse, guys, this gets confusing. Don't confuse B capital R twice with B little r. They're not related. One's boron with two carbon groups attached. One's really boron. But this one is bromine. It left. And you're not going to use Bronsted. You know how you know? It's very easy to know you're not going to use Bronsted. Did you attack a proton ever? Not here. Didn't attack a hydrogen atom. Bronsted's not at play. You're going to see tons of Bronsted, so don't worry. Well, what does it look like when it's Bronsted? You're going to see it within, I don't know. Well, when we get over here, there's big time Bronsted. Wait for it. That's all I can say. Now, this one, this is tricky because this molecule is attacking this, and after that happens, then this happens. So I'm just going to do this. It's confusing, and I don't want it to be. So don't label this step, I'm going to write that right here. Don't label this step. And I'm also going to say the same thing right here, because there's not even two reactants in this one. You can't label if there's not a nucleophile attacking an electrophile. That's what those labels are for. This step. So, and did I misspell label? I think that was in honor of my former teacher, Norman LaBelle. Not quite spelled right, but not these yet. The two mechanisms you have to memorize, activities 3 and 4 today. And they're nowhere near as complicated as this. So right now, you guys, your heads are swimming, I know. I'm just trying to spell label correctly. Is that how you spell label? It was EL. You know, you start doubting yourself when you get older, too. Learning never ends. Okay. So I do want to go to this next step here. This is the attacker. Oh, and I didn't even finish the mechanism over there. Can you guys add a couple curved arrows for me? They're supposed to be on there. I just forgot. There's one here and another here. So let's label those two species, the hydroxide and the hydrogen peroxide. Which one's the attacker? Because you can go lubenu on it immediately. Which one's the attacker? The lubenu is right here. The right side, yeah. And ELA gets attacked, right? And this is perfect because the thing being attacked is what atom? What atom's being attacked by hydroxide? Hydrogen. But it's really attacked because it feels positive, right? What do you call the hydrogen that feels positive? Proton. How do you label reactions where protons are involved? What's the magic name? Bronsted. Is this a Bronsted acid on the left or a Bronsted base? I want to remind you, it's giving up a proton. It's donating a proton. Do not look at the curved arrows when you're doing Bronsted. That will get you in the wrong perspective. Only look at the atom hydrogen. Where did it start? Here, Bronsted acid. Where does it end? Here, Bronsted base. Where it ends is the acceptor, right? Okay, there's water. That's what it made. So, Bronsted acid on the left. Bronsted base on the right. And I'll give you a little checking clue for yourself. You will never have an A be a B at the same time. What does he mean by that? These second letters must always match, as they do here. You will never have a Lewis base be a Bronsted acid. That makes no sense. Okay? But I've seen it, so I don't want it happening again, you know? So if you're going with the Bronsted, it will match the acid and the base that you've already labeled, okay? Good news? Next step is not Bronsted. How do I know? How do you know this is not Bronsted? What are you attacking? Is it a hydrogen? No. So no more BBs or BAs. But the attacker is lubenu, and I want this to be super clear. This label looks like it could be for the other species there, right? So we're doing labels here. This is the lubenu. How come? Well, it's the attacker. It loves the boron's positive nature. And the thing getting attacked is an ELA. Why do I put them in that order? Because ELA definitely sounds like a name. That's why I put them in that order. Okay? Sounds like Eli. Eli. It's a feminine version of Eli. How's that? I made that up. Okay. And then we're not labeling the next one, but we're going in on this one, attacker. I got my Lubnu going. I got my Lubnu. I got my ELA. Getting attacked. And I guess I don't even want to label this step. But for sure, we want to do the last step. It's got all the labels. This has got a combination of resonance and then attacking. So this is the attacker, right? It attacks the molecule on the left, not vice versa. So the attacker is the Lubnu. And the thing that gets attacked is the ELA. And we are done this lovely exercise. Are there any questions? All right.